Let's look at the next combination reaction. So we are basically forming water from hydrogen and oxygen. Now, I'll directly go to the balancing. So very first thing, you need to write all the reactants and the product. And to differentiate between them, we'll put a line. Then we have the molecules, the atoms that has to be listed on the very first column. Now let's count. So there's 2 hydrogen, no oxygen. In H2, in O2, there is no hydrogen, there is 2 oxygen. In H2O, there is 2 hydrogen and 1 oxygen. So clearly oxygen is imbalanced. So to balance it out, I'll multiply this with 2. For here, for it to be 2 oxygen, I need to multiply this entire expression with 2. Right? Only then we'll get 2 over here. Because I multiply the entire expression with 2, by default, the hydrogen, there will be 4 of it. Since on the RHS there is 4, in the LHS there has to be 4, so I have to multiply this with 2. So by default, I have to write 2 over here. Okay. So basically, you'll end up with what? You'll end up with 2H2 in gaseous form plus O2 in gaseous form, giving out 2 times of H2O. Agree? So what is missing? Yes. Heat or catalyst. And yes, this too generates heat itself. Okay, let me write off here. Now, how all can we identify that the reaction has occurred? Very first thing is we have heat that is released. Then of course, very fundamental thing, light is produced. Actually, this is a more fundamental thing. Formation of liquid, that's what I meant actually. Formation of liquid. Now, why does it happen? Well, first thing is, let's look at H2 and O2. What are they? They are non-polar covalent. Agree? While H2O is polar covalent. You can imagine that H2O is more stable and there's an energy difference, and so the heat is generated. So what exactly happens? When we provide H2 with energy, what happens? We have hydrogen radicals. So these are, eager to react. Okay. And similarly, we have O2 and they become oxygen radicals. Again, what is radicals? That too you guys can find in basics. So they are broken. Basically, the bond, single bond and double bond over here are broken. So we form a more stable OH and then further H2O. I'm not going into details, but this is the fundamental stuff. So basically the bond is broken. That's all you guys need to know. Fundamentally. So basically here bonds are broken. So this goes back to our basic definition of correct chemical reaction. Now the question is, why is there a release of energy? Same thing again. The reactants have certain amount of chemical energy stored in them. And when the water forms, they significantly have lower energy state. So there's a difference. So basically, H2 and O2, if they are O here with their energy level, H2O, if they are O here, there's a difference, right? Difference in energy. And this has to go somewhere, and that goes as heat. Okay, and of course, light also is something that we have written over there. Okay, guys, again, don't get too got down with this particular information. It's so that you guys get a feel of the subject, right? And then get a sense of bond and everything, and what kind of energy that there is energy always in all of this, and that energy is used for breaking, and when new things form, that is used for heating, and so on and so forth, explosion, and so on and so forth. Get a feel of it.